Hi physics students. Before we get started, from yesterday we learned how to store numbers in our calculators. There are 3 that are going to need to be stored in your calculators for easy access for you. If you have one of the TI calculators, any version, it's all the same. If you have a different calculator, you may need to ask me in class how to get there, or you can Google it, it'll tell you how. So each time, we did this one yesterday, but in case you don't have it in there, the first thing that you do is you actually type the number into your calculator. So 6.67 times 10 caret raised to the negative 11th power. And then you hit enter. From there, you hit store, STO with an arrow on the bottom left side. Then up at the kind of top, there's a green or blue button that says alpha. And then we want to store this number as a G. So you find the G in the same color as your alpha button, and then you hit enter. Anytime you want that button, you just hit alpha G, and it will pop that number into your calculator for you. You are also going to take time, pause it here, store the mass of the Earth and the radius of the Earth. This way, every time you want to type it in, all you'll have to do is hit alpha M or alpha R, and you will have those numbers already in your calculator for you. All right, from there, yesterday we learned how to find the attraction between any 2 objects at any 2 places. And today we're going to take it a little bit farther. We're going to learn how to find gravity at any location. So whether you're on the Earth, if you're orbiting the Earth, if you're on the Moon, if you're on the Sun, we will be able to find the gravity at that location. Here is the equation for it. Little g is gravity. That is what we're solving for. It is an acceleration, so it comes out in meters per second squared. It is equal to capital G. That's that number we have stored, 6.67 times 10 to the negative 11. It's that standard number that connects the mass and the radius together. M is the mass of the object making the gravity, so usually it's going to be the Earth, but if you were trying to find the gravity on the Sun, it would be the mass of the Sun. It is never your mass. You are not big enough to make anything orbit around you. It would be the mass of the planet. And then R is the distance from the center of the object making the gravity, and it's measured in meters. Okay? R measures from the center of the planet and not the surface. So we will sometimes have to add numbers together in order to find the radius. All right, example number 1, find the gravity if you are 210,000 meters above the Earth's surface. All right, so I want to find gravity, which means I'm going to use this new equation. I need to know capital G, 6.67 times 10 to the negative 11. I need to know the mass of the Earth, 5.98 times 10 to the 24th, because that's what's creating the gravity. And then the only other thing I need is R. That is the distance from the center of the Earth. I am given the distance from above the surface. So if this is the Earth, here's the radius of the Earth, and then I'm located an additional 210,000 meters above. Okay, I need to get to the center, so I need to add the 210,000 to the Earth's radius, which is right here, 6.37 times 10 to the 6th. I am going to add those together, and it is going to give me the full radius from the center of the Earth to the surface, and then an additional 210,000 meters above the surface of the Earth. Adding those 2 together, and I get a radius, and you can have this in a normal number or in an exponent number. I get 6580 with 3 more zeros. All right, that is now my R. Okay, in order to calculate it, I want to solve for G. You can write in the number 6.67 times 10 to the negative 11, or now that you have it stored in your calculator, you can just write a G there as well. The mass of the Earth, you can write in 5.98 times 10 to the 24th, or because you have it stored in your calculator as M, you can just put an M. And then we need to multiply those together and divide it by the radius squared. We have to remember to square this. If you don't, you're going to get a really, really big number. And so you have to remember that's the most common mistake, is forgetting to square your R. All right, into your calculator, the easiest way to do it. You can type in this times this, you gotta use parentheses, or you can just go alpha G times alpha M. It will hit enter and you will get a very large number, and then you'll divide it by the 6580000 squared. Don't forget to square it, and you will find a gravity of 9.21, and it'll be in meters per second squared. Okay, please try typing that in for me. Take a pause on the video. Make sure that you can get that to work. If you don't get it to work, check these numbers that are stored, or make sure that you have the r squared on the bottom. Okay, gravity will always be a normal number. It will never have a bunch of exponents behind it, so it should be a normal number. And if you don't, almost always it's because you forgot to square r. What we can do with this number moves into the second part. To find weight in newtons, it's an equation you've used before. The weight is equal to your mass in kilograms multiplied by gravity. So our weight in newtons, that's how it comes out in the metric system. All you have to do is multiply your mass in kilograms, multiply it by the gravity that you just so found. Example number 2, if you have a mass of 60 kilograms, what would be your weight at the height above? Well, weight is mass times gravity. My mass is 60 kilograms. I'm going to multiply that by the gravity that I just calculated, the 9.21. And if I multiply those two together, I find my weight to be almost 553. I get like 552.6. And weight is always in newtons when you use the equation in the metric system. All right, so we have learned how to calculate gravity at any location. It will always come out as a normal number, not exponents. And then once you know the gravity at that location, you multiply it by the mass, it will give you your weight in newtons. The last piece is how to find the velocity or the speed of an orbiting object. So we've got satellites for your cell phone, for GPS, for TV, like DirecTV, satellite TV. They are all floating around the outside of the Earth, along with military satellites and all sorts of things out there. Okay? In order to maintain that, to not get sucked into, first of all, you don't want it to fly off into space. If it goes too fast, it'll do that. If it goes too slow, it'll get sucked into the Earth's atmosphere and burn up. We want it to have the exact right velocity that it needs in order to maintain the orbit. Okay? In order to do that, you need to know the gravity equals velocity squared over the radius. Okay, so this is the equation to help us find velocity or speed of an orbiting object. I have it labeled on your equation exactly that way. All right, so example number 3. Calculate the speed needed for one of the DirecTV satellites to orbit at an altitude of 320,000 meters above the surface of the Earth. Okay, so if I want to know the speed, I need to know the gravity at that location, and I need to know the radius. How far away from the center of the Earth is it? Okay, I don't have the gravity because it's not 9.8. I am above the surface of the Earth. 9.8 is at the surface of the Earth. It is going to be less, but I need to know how much less it's going to be. So that's going to be my first step. I'm going to solve for the gravity at that location. That is the first equation up at the top. G, 6.67 times 10 to the negative 11. The M, that is mass of the Earth. That's what's creating the gravity. 5.98 times 10 to the 24th. And then I need the radius. Remember, the Earth's radius, we have it labeled as R. It is the 6.37 times 10 to the 6th. I am an additional 320,000 meters above that. So that is this piece. I need to add it to this piece to get my total R. So I'm going to add 320,000. And when I add those two together, I get 6690000. Or sometimes your calculator spits it back at you in exponent form. It would be 6.69 times 10 to the 6th meters. Either one is fine. I find it easier to type it in that way because then you don't have to use parentheses. All right, step 1. I need to find the gravity at that location. I now have each of the things that I need to find the gravity. So it just means I have to type it in correctly. Okay, the gravity is equal to g. You can just write g because you have it stored, or you can write 6.67 times 10 to the negative 11 times mass of the Earth. You can write m since you have it stored that way, or 5.98 times 10 to the 24th. And I need to divide that by not your r squared in there. You have to add two things together. So that's the 6690000. And don't forget to square it. That's the most common mistake. Okay, into your calculator, alpha g times alpha m. Hit enter, then divide by 6690000 squared, and you should get a gravity of 8.91 meters per second squared. All right, that is your step one. Step two, now that I have my gravity, 8.91, and I have my r, still the same number, this right here, I can find the velocity that that satellite needs to maintain. If it goes too fast, it flies off into space. If it goes too slow, it gets sucked into the air. So my gravity, oops, sorry about that. So gravity is 8.91 is equal to v squared over r, same r as before, 6690000. First thing I need to do, I need to multiply this to the other side. So I need to get a big number, and then I'm going to leave that in my calculator because that's not v, that's v squared, so I will have to square root it at the end. Okay, so I need to multiply the 6690000 to the other side, multiply by 8.91. When I do that, I get a super big number. I got like 5962122 Leave it in your calculator, all right? From there, you just need to square root it, and if you hit, on your calculator, I hit second square root, second answer, it dumps in that, so I don't have to type it all in. Then you will find that the final answer is 7721 meters per second. So it needs to go almost 7,800 meters per second, which is approximately 7,200 miles per hour. Super, super fast. It needs to move very, very quickly in order to maintain that speed, and they're constantly accelerating it in order to get it up to the speed that it needs to maintain. All right, so 3 new equations. Well, I guess 2 of them are new, 1 of them is old. Our gravity at any location is that one right there. Once you know the gravity, you can find the weight in newtons. And finally, if you want to know the speed of an orbiting object, what it needs to maintain, you can use this one right here. There are problems that go with it on the back. Thank you very much.